On the last talk, thank you, Trevor, for doing that to me. So I can do this even faster, although it would be worse if we were all in person and there was cold beverages waiting outside the room. So uh, I will attempt to fill 15 minutes. I could probably do it faster than that. I just offered to Trevor. Oh, by the way, I can introduce myself. Anyone who doesn't know me, I'm Bruce Ashfield. I currently work for AMD and I maintain the kernel and some of the other layers within the Yocto and open embedded ecosystem. And I'd offered to Trevor, rather than doing the full Linux Yocto talk or some of those I've done in the past, to just do a quick update on sort of, again, I'm contractually obligated to myself to always tell people that what the reference kernel is and why it exists. And then, just a quick summary of the current status, what versions we're at, where we're going. I'm going to do a mini readout of the mini conference at Linux Plumbers, where I talked about kernels as part of the build system, as part of that mini conference, and then a little bit of future work. So without any further ado, these are picked from one of the previous summit slides. Some of them, they're modified slightly. But again, why do we have a reference kernel in the Yocto project in OE Core? It is a best effort to resist at least some level of version fragmentation and expansion, because as we know, we would actually have one kernel for every single version if we didn't at least try to gather some momentum and gravity around particular versions. So it also provides as a baseline for security maintenance, and it has a predictable cadence, so you can count on sort of what the updates are going to be. I have a little bit more on that future on, that some of the things that we've counted on for the past 4 or 5 years are changing slightly, so our cadence and our versions will change accordingly. And again, we may have some embedded or project specific changes. Those are minimized because we have been able to throw away and update and get rid of some patch sets over the past decade or so. So, for instance, we used to have a bunch of tiny patches for Linux Yocto Tiny. Now it's mainly a configuration because all the important ones made it into the upstream kernel. So we don't actually carry changes for that anymore. Again, so what we use it for as part of the testing is we exercise a lot of the kernel workflows, packaging init ramfs's and SDKs and kernel dev source and on target compilation and things like that. The tightly coupled tools like perf and things like that are exercised through the reference kernel recipes and repositories. It also lets us do some of the tightly coupled package validation. Those are the ones you'll see me sending changes for every time I upgrade the kernel, usually perf, LTTNG, system tap, some of the out of kernel modules, things like that tend to blow up as we upgrade kernel versions. We have some vertical and specific configurations testing, whether it be the preempt RT stuff, tiny, developer kernel, standard, kernel.org, things like that. We can test specific configurations out of a single tree. We have the ability to collect some contributed BSPs and the configuration fragments, and that configuration extended model is sort of one of the points of gravity around the reference kernel. Also, we use it to detect and fix issues early, because there's always, even though you'll see the versioned reference ones that have been fully tested, there's always the dev kernel chasing sort of the latest, and that's where we pick up as best we can. We could even do more with the dev kernel, but it's a time and resource thing where the amount of effort we put into putting out a reference kernel version is significant. So not every single dev kernel gets the same level of testing, but the big thing is it supports the validation and testing of the entire ecosystem, and it leaves us up to fixing sort of the hard problems, the ones I call the ones that nobody cares about except us. So look at the recent, 6.1 x86 intermittent hang, the 6.5 intermittent serial issues, the one that's ongoing with some sort of FPU initialization intermittent problem. Again, we pick these up in our testing, and we're always told that nobody else is seeing them until we narrow them down. Lately, usually thanks to Paul Gortmaker reproducing them and helping us out specifically. But that's the big thing with the reference kernels, is even though other people aren't seeing them yet, they inevitably or eventually will. And so we try to fix them before they get to them. And my page down is no longer working. Oh, there we go. Just some lag. So the possible versions that you'll find for the reference kernels, if you want to find more details, I did a whole talk on it, Linux Yocto reference maintenance and kernel workflows in May 2021. There's usually 3 versions per release, sometimes 2. For example, this spring one may just be 2. We'll see. There's an LTS, there's the current, and there's the dev. And the Linux libc headers is usually the LTS or the latest. Again, it covers all major architectures, 20 plus boards, 3 kernel versions, 20 BSBs, machines, and 3 kernel types. So you do the multiplication on that. There's a lot of combinations that are validated at any time. And the version selection is predictable and documented. I should have put a link in here, but it's somewhere in the documentation or in the wiki pages when and how we pick the versions. The maintenance and update cadence for the various kernels, reference kernels, is weekly, is sort of the dev kernel, stable, which would be the current and the most recent LTS. Actually, that's wrong now. It's actually, I'm still doing updates to Dunfell. So how about we say 2, sort of 2 or 3 versions back. Monthly, I'll do monthly updates to the older stables, sort of the older LTS, if you will. Bi-monthly, the dev kernel upgrades. Per release, new and current dev LTS, but bug fixes on demand, they're always going. And of course, updating the user space to tightly coupled packages if required. The configuration fragments are updated per release, and they're refreshed for every single current and dev kernel version. That way we pick up obsoleted configuration options, things that are now no longer able to be modules. The audit tools pick those up when I'm working through the dev kernel. So there's a refresh on those to make sure that we're at least roughly keeping the configuration bits of the kernel up to date with the latest. Again, people always ask this. What are the branches in the Linux Yocto repository? There are branches for the mainline kernel unchanged. The mainline plus stable, real-time, tiny, the Yocto, and SDK. Dev is a separate repository. In theory, it could be the same, but since it gets rebased sometimes, rarely anymore, but it could happen, it's a separate repository. So the mainline kernel is whatever the version is /base. So v6.5 base is the pure kernel.org plus Greg's stable updates once they start going out. So if you build that, you get upstream. Yocto plus stable is you get the standard in the middle. The real time is standard preemptive RT base, tiny, standard, tiny base, and the kernel cache always matches Yocto and then the kernel version. And all of those branches get every single update from stable or a CV at the same time. And then I'll put out a release with the source web bumps. Here's what they look like. It's pretty simple. It's a tree structure, but in case you're ever wondering what's on the branches. And actually what is in all those branches is also tracked in the Yocto kernel cache, so you can actually just find the patches if you don't want to do the git foo to figure out the deltas in those branches, because once they're created, those branches are never rebased and they're sort of fast forward forever. All right, current status. Versions, and more versions. In the latest, in the release that just went out, it is currently 6.1 to 57, 6.5 to 7, and v6.6 is the dev kernel, and the Linux libc headers are at 6.5. There's more versions. There's more stable updates to all those versions pending, but I had a build server disk failure earlier this week, so I'm now only today starting to pull my in progress changes off of that server so I can send out the stable updates again. Kirkston is 5.10.192, 5.5. No, so anyway, the point is I'm continuing to do many, I've gone through roughly, very rarely do we jump to stable versions, only if I was really busy that week does it not happen. So there's been 180 plus updates to 5.10 and 100 and I'd say 15 plus updates to 5.15 in Kirkston. Dunfell, it's at least 5.4.257. And again, so that you go 200 plus times I've gone through updating the stable revisions for that. And the other thing that I took out because it was causing us a pain is I had in my release scripts to update the CVE tracking Inc. files, but the problem was basically that I realized after is because I was doing the source rev bumps and the CV update is a single commit. And then if somebody else updated it because they were waiting for my stable, which don't always come out at the same hour every day because I'm not a bot yet. And so I have to do some extra work to validate some of the kernels. If somebody else updated, it was a pain to rebase my changes on top because the conflicts were just annoying. But I will do them as separate commits, and that way I can just simply throw away my commits and redo them and leave the source rev bump. So that will be re-automated in the not too distant future. I wanted to give a quick summary of Linux plumbers. I presented the kernel build system outputs and how to balance them at the Linux plumbers in Richmond, Virginia recently. Great city. If you haven't been there, I don't know, maybe don't go there. I'll get in trouble for saying that. I didn't get to see much of Richmond. The reference kernel, as I was talking about there, the reference kernels, they drive and produce much more than just test images. We're talking about everything from the kernel dev source to init.ramfs to kernel modules to system maps, all the file. There's multiple different outputs, whether they're signed or not, and different things that get produced from the kernel. And the reference kernel is what sort of drives us to make sure those continue to work. There's multiple different personas and workflows to balance, whether you are doing load build, whether you're a developer, whether you're doing a bug bisection. There's all kinds of different workflows, and no build system can actually do them all really well. And that we found out that sort of our build outputs are probably more complex and possibly more comprehensive than many other build system. And that's good and bad because we're all afraid to touch some of the kernel packaging classes because they're unchanged since the beginning of time, and there's all sorts of things that depend on them. But the good thing is that we are at least following the latest and supporting flexibility, which gives us our complexity. What's next? For the next release, the LTS in the spring, we will be, I was going to introduce it, but aforementioned build machine failure has me just pulling those kernel updates off of it now to get them ready. I bumped libc headers to 6.6. That will more than likely be the libc headers, so we'll stick with the LTS. Kernel 6.6 will be the next reference, and of course 6.7 will probably be 6.8 will be the dev kernel. I won't do a version, say 6.8, because if we put the LTS into support said versioned, newer version reference kernel, we'll go EOL and we'd have to actually remove it from the LTS release, and that's sort of a pain, so we won't do that. In the kernel fragments, there'll be some new ones, some refactored. For instance, Ross picked up that we had some debug on that was causing more performance overhead than it was worth, so I've refactored some of those. I've tweaked the audit to give us a little bit more information about not just hardware options, but all options. And we have a bunch of people that have been asking recently about taking their def config and creating a kernel Yocto based fragment BSB. So I'm brushing off a tool that I wrote about 9 years ago to update it to the latest. I haven't been able to listen. The first day I didn't listen to any of the talks because I was, again, saving said aforementioned dead server. There's reference board refreshes, so those, of course, will appear and be supported in Linux Yocto as the case happens. And we have to come up and document a plan to deal with the upstream support changes. Because at the same time, they were sort of announcing that 6.6 is the next LTS. They also said that it's unclear, but it will only be supported for either 2 or 3 years, if you will. But either way is less than our typical LTS support window. So as Richard mentioned a couple times, and I've mentioned, the rough plan is we will figure out how to potentially introduce a newer kernel partway through our LTS, because we are not scaled nor plan to scale to handle the entire stable queue and say keep that version maintained on our own. We tried it. Paul Gormaker did it a couple times, and it's, yeah. You need an expert to do it, but it's not something an expert wants to do. So it really doesn't, it's just not feasible. And what's next, meaning will never happen. I don't know. Maybe might happen, could happen, maybe. So when there's time, enhanced testing, because we have found some unique issues and we could even probably find more or do more. Do a little bit more kernel specific on target testing using some of the built-in tests of the kernel, do more stress testing, actually enhance our additional kernel type testing, whether it be real time with a dev kernel, look at better support for some new architectures. Probably you could read into that, say RISC-V, for example, as part of the binary reference distribution, produce some better generic binary reference kernels, expand our boot testing coverage, meaning maybe some more hardware targets and more image types than we currently are doing. One of the outputs from Linux plumbers was that, as I said, the developer workflows, you can't get a kernel guy to actually use a build system as part of his kernel development workflow. So there's probably some opportunities to streamline some of those workflows. And then to not reproduce what everybody else is doing, but come up with some of our own performance tracking over time, so we could pick up, for example, when a debug option gets turned on that is adding extra overhead and slowing down our performance, that we would see it ourselves versus somebody else having to notice it. And that's it for me.